Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn Class 9th Physics Chapter Work, Power and Energy, and this is our part 4. In this part we are going to learn the different points, different expressions to calculate work. So we have learned A and B. We will start with C. Work done by a force that makes the angle with the direction of displacement. Work done by a force that makes the direction that makes the angle with the direction of displacement S. We have seen that whenever work is done, a body displaces this in the same direction or in any direction of the force applied. But in some cases, the body moves in a direction that makes an angle with the direction of the applied force. For example, when a child pulls a toy car using a string attached to it, the car moves horizontally on the ground, but the force applied by the child is along the string held in his hand, making an angle with the direction of the displacement of the body, which is horizontal to the surface of the ground, like this. X. This is point O over here. This is car, toy car. The child is pulling it from this side, and this is the direction of force, and this is the direction of displacement. This is the direction of motion, and this is the angle which is called theta. Point A. In this, the toy car moves along the horizontal ground surface OX, but the force is along the string OA. Thus, the direction of the force makes an angle theta with the direction of the motion. In such cases, we cannot use the formula of work done is equal to force into displacement. To calculate the work done, as the displacement S is not exactly in the direction of the force applied. So therefore we need to know the magnitude of the force in the direction of the motion of the body. Let us try to find the magnitude of the force F that acts horizontally, as force is a vector quantity and makes some angle with the horizontal. It can be resolved into two components, parts, like this, car, like this. First, the component of the force along the direction along the direction in which the body moves called horizontal component of force, that is FB. Second, when a lawn roller pushed by a person to level the pitch of a cricket ground, the force does the work since the roller displaces in the direction of the force applied by the person. Third is, and the other component acting perpendicular to the horizontal, that is vertically upwards, called vertical component. The vertical component tries to lift the body but does not actually lift it. Therefore, the vertical component does no work as there is no displacement. So, displacement vertically upwards. The work is done only by the horizontal component of force Fb as the body moves in horizontal direction. Fh can be expressed in the terms of f and theta. In the terms of f and theta, Fh can be expressed in terms of f and theta. So from the figure, cos theta, trigonometric property, cos theta is equal to adjacent side of theta. This is theta. Adjacent side of theta is this. Adjacent side of theta is this. This F adjacent side upon the opposite side of theta. Opposite side of theta. Cos theta is equal to adjacent side upon hypotenuse. Hypotenuse. That is OX upon OA according to the figure. OX is the adjacent side and OA that. Now, from here, there are some values of cos theta and its value. When cos theta is 0 degree, the value becomes 1. When the cos theta is 30 degree, the value becomes root 3 by 2. When the cos theta is 45 degree, then the value becomes 1 by root 2. When cos theta is 60 degree, then the value becomes half, and when the cos theta is 90 degree, the value becomes 0. You have to remember this because we have not yet started trigonometry in mathematics. When we will start trigonometry, then you will get to know what are this cos theta and all. In this chapter, only cos theta. This is main useful. Then the formula from this, which derives is f cos theta s or fs cos theta. This is the formula for solving. Force into cos theta, the value of cos theta, and s is the displacement. Cos theta is adjacent side upon the hypotenuse of the theta. Like this. Now, there is fourth, work done against gravity. D. Work done against gravity. Consider a book or an object lifted from a table. We do work against the force of the gravity. Whenever work is done against gravity, the force required to lift the body is equal to its weight. Therefore, the amount of work done is equal to the product of the weight of the body and the vertical distance through which the body is lifted. Suppose a body of mass m is lifted vertically upward through a distance of h. Then the force required to lift the body will be equal to the weight of the body, mg, weight of the body m into g, where g is the acceleration due to gravity. Thus, work done by the person in lifting a body is equal to the weight of the body into vertical distance. So the formula derived from this whole example is force is weight is work done is equal to mgh, m into g into h. When work is done against gravity, w is equal to minus mgh. When work done against gravity, acceleration due to gravity is taken as minus g. The magnitude of the work is always positive. In this case, the magnitude of the work is always positive. Example of work done against gravity. There is examples of work done against gravity. When a suitcase is lifted from the ground to some height, the work is done against gravity. Because gravity is downwards, it takes any object to the downwards, and when we do anything against gravity, we use this formula. It is possible that when you do work on a body, the body does work on you. Take the case of a weightlifter. The weightlifter lifting the weight. When he applies a force on the weight, a reaction force by the weight, a reaction force by the weight acts on the hand as per the Newton's third law. The action force by him on the weight is in the upward direction, while the reaction force by the weight on him is in the downward direction. It is clear that the action force does positive work and the reaction force does negative work. In fact, this negative work on him is responsible for the supply of this energy for him. The positive work on the weight is responsible for supplying this energy to the weight. From this, we can draw an important conclusion that if there is positive work on a body, there has to be a negative work on the other. There are many examples of the zero work. The examples of zero work we will learn in part 5. Then we will see some problems based on work. Till that, I hope you've understood this part 4. For any queries and doubt, please join the Telegram link given in the description of this video. Like, this is the foundation of class 9th. We have covered the foundation of class 8th too. The links are the 8th and 7th too. The links are given in the description. Please go and check through it. Thank you for watching. Let us meet in part 5. Thank you.